Hey viewers, this is Devinder Kaur and welcome to my YouTube channel, The Enlightened Room. In this video, we're going to talk about the problems that are based on the Newton's law of gravitation. Okay, we're going to solve these problems with the complete clarification. Okay, so as we're talking about the Newton's law of gravitation, you must remember its formula. What was its formula? Its formula was F equals, that means the gravitational force of attraction F equals the universal gravitational constant G times the product of the two masses we are going to talk about. Okay, as F lies between the two masses or two objects over the distance between the two masses, and that distance would be squared. That means r squared. R is the distance between those two masses and that would be squared here in the formula. Okay. Now let's move on to our first problem. The first problem states the gravitation force between two objects is F. We have two objects, object A, object B. These two objects has masses m1, m2. There is gravitational force of attraction between these two objects, and of course there is some distance, and this distance is taken from the center of these two bodies. Okay. Now how will this force change when the distance between them is reduced to half? Of course the force will change, but how? When the distance between them is reduced to half, that means the objects would come closer, right? Here is object A, here is object B. They have came closer because the distance has been reduced to half. Of course we're going to take the distance from the center of these two bodies. The masses would remain same. Now, as this one is also a distance, this one is also a distance. Suppose this distance was 4 and as it has been reduced to half, this distance is 2. We cannot name it as R, same. I mean with the same R, we're going to name it as R1. The new distance as R1. Okay. Now, if you remember, okay, first of all, let's finish this one. Of course, there would be the change in the forces. I mean, this one would also be named as F1. Okay. Now, why this has been changed? The force of gravitation has been changed. Okay. Let us assume we had the value 4 for the distance. You would have put the value 4. There would be the value of F. If the distance is reduced to half, that means the 4 has happened to be 2. There is 2 square. In the previous one, there was 4 square. That would be 16. In this one, there is 2 squared, that would be 4. Of course, there would be change in force. Okay. So here is F1. Now, how come this would have changed? You clearly can see from this formula, this force, I mean the gravitational force of attraction, is inversely proportional to the square of the distance between these two bodies. Right? These two are inversely proportional to each other. So, what would happen, as this one is for this problem, for previous one, if the distance has been reduced to half, that means R1 is 1 over 2R. The gravitational force of attraction would also be changed. It would be written like this. Now we are going to try to find the change in force. Of course, what we are going to try to find the change in force, and that how will we find, as we will try to relate them. Okay, we will try to relate them by dividing these two forces with each other, and F dash, I had written F dash, here is F1. You can write this distance as R dash or R1 as you like. Okay. Now this F1 would be equal to 1 over R1 squared. This F would also be equal to 1 over R squared. This would go like this. Okay, and then when we try to solve it, this one would go here with the reciprocal. The numerator becomes the denominator and the denominator becomes the numerator, and this would be written like this. Okay, this is how it comes. Okay, now we're going to put this relation here in this one. That means we're going to put the value here. That would be 1 over R over 2 squared, and here would be R squared. Okay, now this 2 would go on the numerator side, F1 over F would be equal to 2 squared, that means 4r squared times r squared. These two r squared would be cancelled. We would be left with F1 over F equals 4 over 1. Okay. Now what will happen? There would be cross multiplication here. F1 comes out to be 4 times F. Now what does this say? That means the new gravitational force of attraction is 4 times than the previous one. That means if the distance between the two objects or two bodies would be reduced to half, the gravitational force of attraction between those two objects would be 4 times the original one or the previous one. Okay. Now let's move on to the second part of the first problem, which states that how will this force change? How will this force change when the mass of each object is quadrupled? That means the mass would become 4 times. Now we had two objects, A, B, of masses m1, m2. As the mass has become 4 times, these would be like this. And of course there would be change in their denotation. That would be m1 dash, m2 dash. The distance would be same in these two masses, but the force of gravitation would change like this, right? Okay, not from the middle, not from the within, from the outside. The arrow would be outside. Now you all can see this formula, F equals G m1 m2 r square, which has been given by the Newton. Okay, according to this formula, you all can see the gravitational force of attraction is directly proportional to the product of these two masses, right? That means this is the second part of the first problem, F is directly proportional to m1, m2. Now the new mass m1 dash is equal to 4 times m1. It is 4 times the previous mass. Similarly, m2 dash is 4 times the previous mass m2. Okay, so the new formula for the new masses would be F dash equals m1 dash times m2 dash. That means directly proportional to the m1 dash times m2 dash. Now we are trying to find the change in force. So how we will find it? Of course, again by relating them as we did in the first part, F dash over F is equal to m1 dash times m2 dash over m1 times m2, right? Now we're going to put these two values here. That would be 4 times m1 times 4 times m2 over m1 m2. Okay, these m1 and m2 would cancel each other. We would be left with F dash over F equals 4 times 4 is 16, and this would be our relation like this. Of course, the cross multiplication would be here like in the previous one. There would be F dash equals 16 times F. Now what does this thing mean? Well, this problem is very important for the MCQs, for the problems, for solving the problems, for the reasoning questions, for 1-mark questions, for everything. Okay, so pay attention here. Now what does this mean? If the mass of each object becomes 4 times than the previous one, then the force of the change in force would be 16 times from the previous condition, from the previous force. Okay. In this one, if the mass has been reduced to half, the force had become 4 times. If the distance has been reduced to half, the mass would become 4 times. And if the masses becomes 4 times, the force of attraction would be 16 times. Okay. Now let's move on to the second problem. In the second problem, I am going to erase and you are going to read the problem. In the second problem, we have a sphere of mass that is of 40 kilograms. That means it has the mass of 40 kilograms. Is attracted by a second sphere, and that second sphere has mass of 15 kilograms when their centers are 20 centimeter apart. That means the distance between them from the center, taken from the center, is 20 centimeter apart with a force of 0.1 milligram weight. That means the gravitational force of attraction here is 0.1 milligram weight. We are trying to find the value of gravitational constant. Okay. We are provided with M1. We have two masses here. One is bigger and the other is smaller. We have M1 as 40 kilograms and M2 as 15 kilograms. The distance between them is 20 centimeter and the force of attraction between them is 0.1 milligram weight. Right? I'm going to write it short now. M1 is, how to write the formula, how to systematically write the solution of a problem we're going to learn here. M1 is 40 kilograms, M2 is 15 kilograms. Now the distance between them is 20 centimeter. In the Newton's law of gravitation, we had studied the units, right? Was there any centimeter? No, there was meter. So we're going to convert this centimeter into meter. We know that 1 meter equals 100 centimeter, right? So that would be 20 over 100 meters and that would be equal to 0.2 meter. And the force is 0.1 milligram weight. We're going to convert it into gram weight, then to the kilogram weight, and the kilogram weight would be 10 to the negative 7 kilogram weight, and 1 kilogram weight equals 9.8 newtons. That means this would be equal to 9.8 newtons, 9.8 times 10 to the power negative 7 newtons. The F would be like this. So we're going to trying to find G. You know F equals G M1 M2 over R squared. That means G would be F R squared over M1 M2. Now we are going to put the values. There would be 9.8 into 10 to the power negative 7 Newton times 0.2 meter squared over 40 kilogram times 15 kilograms, right? So we're going to solve it on the calculator, and after solving you will get the approximate value of 6.593 into 10 to the power negative 11 Newton meter square over kilogram squared. So this is how you will find G here, the universal gravitational constant. Well, this one was pretty easy. The first problem is very important. Pay attention when you watch the video. Okay, so this was up for today's video. We have solved the two problems here. The first one is really important. Okay, this one comes in the MCQs and other questions. So hope you liked my video, and if you haven't subscribed to my channel, then subscribe to my channel and hit the bell icon. Thank you so much.